example 13 gives us a function. It's a quadratic, right? Negative 2x squared plus 7x minus 3. And it asks us to find f of negative 1. So that means just plug negative 1 into the function. So if we do that, f of negative 1 is negative 2 times negative 1 squared plus 7 times negative 1 minus 3. So this is negative 2 times 1, which is negative 2, minus 7, minus 3, and we should get negative 12. Part B asks you to find the difference quotient. So the difference quotient is listed on the previous page for you. Okay, it's right here. This is a really famous formula. It comes from the rate of change formula. And it says, right, that we need to evaluate f of x plus h minus f of x all over h. So typically this question might also be followed with like simplify as much as possible. So one of the biggest questions that students have when we do difference quotient problems is like, when do I stop the problem, right? You stop the problem when the h in the denominator is able to cancel, right? That's when you're done. And there's also some patterns that will emerge when we're doing these problems, and I'll show you these as we work through it. So one thing I think is helpful, especially when you have a polynomial, is to sort of scaffold this out a little bit, right? So let's figure out what f of x plus h is first. So that's negative 2 times x plus h squared plus 7 times x plus h minus 3. So then I need to expand this out. So this is a quadratic. We can FOIL it out. And I'm going to get x squared times negative 2, so negative 2x squared. The outside terms are x times h times x, or plus x times h, so I get 2xh, but then I need to multiply that by negative 2 and get negative 4xh. H times h is h squared, but when we multiply it by negative 2, I get negative 2h squared plus 7x plus 7h minus 3. So now I'm ready to plug this into my difference quotient. So the first thing I'm going to do is I'm going to take this, right, and plug it in for this. So I'm just going to rewrite it. So negative 2x squared minus 4xh minus 2h squared plus 7x plus 7h minus 3. And then this is very important. We're subtracting f of x. F of x is not one thing. It is an expression of things. So I need to make sure I put parentheses here because I have to distribute that negative sign across everything. And all of this is over h. So what should be happening here, right, is we should be able to combine some like terms. And if you've done your algebra correctly, hopefully every term in the numerator without an h should disappear. So let's see if this is going to happen. So negative 2x squared, well down here I have a minus 2x squared. So this is actually positive 2x squared. So these two terms are going to cancel. Then I have a positive 7x and a negative 7x. So these two terms cancel. They're adding to 0, right? Then I have a negative 3, and then I have a minus a negative 3. So that ends up becoming a plus 3. So these two terms add to 0. So now if I write what's left, I have negative 4xh minus 2h squared plus 7h all over h. So since every term in the numerator has an h, I can factor it out front and get minus 4x minus 2h plus 7 all over h. And now I can cancel the h in the denominator. The second that guy's gone, this is your final answer. So that is when you are done with the difference quotient problem. You have to make sure that original h is gone, and that if we say simplify completely. The last part of this problem says, we'll find the average rate of change of f on the interval from 1 to 3. So the average rate of change is f of b minus f of a over b minus a, where the interval is always expressed from a to b. So you should be able to read the interval on a number line from left to right, and we always do the final thing minus the initial. So f of b and f of a, right, are going to be f of 3 minus f of 1 over 3 minus 1. So if we plug 3 into f, we get 0. If we plug 1 into f, we get 2, and 3 minus 1 is 2, so we can see this simplifies to -1.